Hi guys, I'm Deepak Kumar. I'm Chairman and CEO of Microsoft Corporation. I'm going to take class on advanced C programming. It is not for college students. It is for programmers who are already doing C programming. Maybe IIT students can learn. Let's get into the subject. First, I'll start with pre-increment. What is pre-increment? Means first you have to increment the operator and then assign the value. I'll explain it. First, here I is equal to 0. What happens here? Since plus comes before I becomes I becomes 1. I becomes 1 and then we are calculating whether I is less than or equal to 10. First I becomes 1. That is what you should be carefully noting down. First I becomes 1 because plus comes before I. So I is less than or equal to 10. This is going to print. Now I is equal to 1. Here after it becomes 1, here also I is equal to 1. Now we'll get into the post increment operator. What is post increment operator? Here I equal to 0, plus comes after I. Plus what happens? It comes after I. So what happens is I is given the value of 0 first and then it is incremented. So what happens is I is equal to 0 is assigned here. 0 is less than or equal to 10 is compared first. Then what happens is in this place itself, I becomes 1. So when it comes here, I becomes 1. So don't expect me to tell what is the output of this program because it will run for 10 times. So it is a child's play, you know. So I'm trying to explain. What I'm saying is what is post increment means first I is equal to 0 first comes first and then here itself I I, I becomes 1 but I I's value is not assigned here. It is incremented, but I equal to 0 is assigned. Here I is equal to 1 is assigned. Okay. Now we will see post decrement. Don't be scared by this program. It is very simple. See what happens is here x is minus. What happens is first x is assigned 3 and then it is decremented. What happens is here x is 3 first. When it comes out, it becomes 2. Right? Now we understand very well. First here x is 3. When it comes out, x is 2. Okay. So if you calculate this, 3 minus 1. What happens? That is equal to 4. Because 3 minus of minus 1, what is it? 4. But x is post decrement. So when it comes out, it becomes 2. Here x is equal to 2, z is equal to 4. Now we will see post increment with two variables. So what happens is, so we should always calculate, if there is more than one variable, we should always calculate from right to left. Okay. So here also it is post increment means first x is assigned value 3, then it is incremented. Here also x is assigned value 3, then it is incremented. So what happens is 3 z is equal to 3 plus 3. But when these two x's come out, it is not 1 4. It is not x plus 1, it is x plus 1 x plus 1. There are two x's, so it is x plus 5. So here x is equal to 5 and then z is equal to 3 plus 3 6. Okay, now we will see the combination of both post and pre-increment. Okay, what happens is it is always we have to calculate from right to left. So here what happens is this is pre-increment. So first x becomes 4. Here x is 4. That's why here also x is 4. So you have to be careful first. Here what we are doing is x becomes 4 because it is pre-increment. So if you see the x value here, it is 4, but it is not incremented. Here only it is incremented. Here it is not incremented. Here x is incremented as 4. Here it is not incremented. Here it is assigned the value 4. So z is 4 plus 4. So z value is 8. But see, when it comes out, when x comes out here, it comes out as 3 plus 1. Here also it comes out as 3 plus 1. Why? Because we are not assigning it to any variable. We are just adding these two variables. If we assign it to any variable, it will increment. Okay, guys. Now let's see pointers. Pointers is not a difficult concept. You just have to be. It is an easy concept. See, I'll explain. See, first I is a variable. It holds a value 30. Now what is j? J is a pointer. It points to the variable I. What is k? K is a pointer to a pointer. It points to the pointer j. Now what is a pointer? Pointer means j is a pointer. What is a pointer means? J points to an address which holds the value. Means j points to I holds a value. That's all. What does j have? It has an address. I is stored. I has a value 30, and 30 is in an address, and j holds the address of it. That's all. J has an address of I. Now what is K? K is pointer to a pointer, means K points to J. J is itself a pointer. So K points to J. J is itself a pointer. Now we'll see what is address of I. Address of I is, you can say address of I simply by putting ampersand of I, because I is a variable, or you can say J, because we know that J is a pointer to I. So if you put J, it will give output of the address of I. Star K means it point. This is a pointer to a pointer. So star K means it will point to J, then it will point to I. So if you put star K, it will show the address of I. So now address of J. You can put address of J or K. So these are very simple things you can easily understand. Now the address of K is, you just have to put address of K. Similarly, if you want to value JI, you can either put I or see address of I, value in it. See, star means it shows the value in it. Ampersand means it shows the address in it. Star is value, ampersand is address. This you have to always be very careful and understand it. Ampersand is address, star is value. Star k means what it takes the value out of k. 2 ampersand means, see here 30 comes. It k has a two addresses. It goes to point 2 point address. K points to J points to I. So it goes to I value. Yes. Okay. Now we will get in the example of this pointers. So here k is equal to 35, and there are two pointers z and y. So z is pointing to k and y is pointing to z. That means both y and z are pointing to this variable k. So here what is happening? Star z plus plus equal to star y plus plus. Here we are not. First, what happens is we are incrementing y plus plus and z plus plus. So first, what happens is y plus plus is increment, means we are incrementing the address of y plus plus. Y is first pointing to 1008. Suppose k is pointing to some address 1008. Z y plus plus was incremented to the next address 1012. It is assigned to the value z plus plus. So then the value in it is assigned to z. It may have garbage value, any value in it. So this is what is happening here. Are we incrementing the value of k equal to 35? No, no. Here we are not incrementing the value of 35. Here what we are doing is we are incrementing the value of y plus plus, means we have this y is an pointer. We are incrementing the pointer. We are incrementing the address of it and assigning it to the z address. Here is k plus plus is incremented. Then we are printing it. So if you simply say z plus plus, instead of star we leave star, and if you simply say z plus plus equal to y plus plus is same as such. But the only thing is it is same as such. We don't care what is the garbage value. It is same as star plus plus. We don't care about the garbage value. The common notation between pointers and arrays. So first look at this. So this is n of 0. This is same as star n, and this is same as star n plus 0. This notation is very important. If you understand this notation, you can solve all these problems. N of 0 is equal to n star n, that is equal to star of n plus 0. That means n of 24 equal to star of n plus 24. That means it is applicable to all values. A of 25 equal to star of a plus 25. C of 1 is equal to star of C plus 1. You should understand this notation. Now see this example. N of 0 equal to 100. N of 24 equal to 200. Now we print it. Star n is equal to star n of 0. That means it will print 100. Now here star of n plus 24, this is equal to n of 24. This is 200 plus this star of n of n plus 0 is equal to n of 0. This is 100. If you add 200 plus 100, this is 300. Now we will see pointer to an array. So pointer to an array is very simple. Don't get scared by this notation and all. It is very simple. Okay, I'll explain it. Here, this is an array. So this is a normal array. Array of bracket of some array, any number of elements, and this is a pointer, simple pointer. This is a simple pointer. So first we have to point this pointer to the base element. How we are pointing to the base element? Through address of base element 0. Address of AR of 0. And what is the last element? Pointer is what is the condition? The last condition till it stops. Pointer less than or equal to address of 4. Till this pointer moves from 0 to 4, keep on going. Pointer plus plus, then plus plus, keep on going, and then print star pointer. Star pointer. That's all. It prints 0, 1, 2, 3, 4. It is as simple as that. Here we are again seeing pointer to an array. Another example of pointer to an array. See here, the main point is this is a normal array. This is a array of B having 5 elements. So this is a pointer K. Now K points to the last element. So B of 4. So this is B of 0, 1, 2, 3, 4. So k points to the last element minus 4 means it comes to the first element. So why it comes to the first element? Address of b of 4 minus 4 is equal to address of b of 0. It doesn't mean, yes, if you put minus 1, the address of variable is incremented by 1, it goes to the next address, which is as many bytes away as the data type of the variable, which means if it holds a number float variable, it goes the next float variable. If it holds the character variable, it goes to the next character variable. So it holds the data type. Whatever is the data type, it holds the next data type. So this minus 4 means it goes from 50 to 10. So then this is as usual as printing. So what happens is from I to I plus plus, from 0 now here minus 4 means from address of B4 minus 4 means it has come to 10. So I is equal to 0, I plus plus. So from here to here, it means k star. K star means in this value. Now k plus, you increment it and it means value 10 to 50. As I said earlier, guys, this is another notation. See, here this is an array A. This can be represented as star A plus I, as well as A of I, as well as I of A. See, this is also possible. This is also a valid notation. Here, star of I plus A. So star of A plus I is same as A of I of A, and star of I plus A. This you have to remember. Now we will see another example of pointer and array. So this is another array. An array which has 4 elements 0, 1, 2, 3, 4, and there is a pointer PTR. So what we are trying to explain in this slide is ARR. If you represent an array as ARR is same as a address of ARR of 0. You simply put an array as ARR, it is same as address of ARR of 0. If you put ARR plus 4 means it is same as ampersand of ARR of plus of 4. This is what we are trying to explain here. If you understand this concept, this we can explain. So okay, what we are doing here is we are pointing a pointer from this place to this place, and we are printing it. That's what we are doing it. So what we are explaining it is here. This concept we are explaining. So this pointer is pointing to array of plus 4. Array is this address. Array, we know array. What is ARR? Address of 0. So this points to 0. So plus 4 means ARR plus 4 means ARR of ampersand of address of 4. That means it's 4. This here we are address of 4. This address it is holding here. So pointer equal to this address. Pointer is less than or equal to this address. Pointer minus minus. Now what we are printing is array of pointer minus array. That means we are numbers means here address minus address is equal to number. It will come numbers. It will come what number it will come? It will come 4, 3, 2, 1. It will come numbers. If you put that, this number will come 4, 3, 2, 1, 0. So it will be little time take grasping. This will time take to grasp it. So just take time to grasp it. So what we are trying to explain is this concept.